So friends, again we will start the one or two slide. Today is our sixth lecture of this course, and the second unit we are going to cover the solar radiation in the second unit. Solar radiation I divided into small virtual class time, 30 or 30 minutes. Already we have spent 10 minutes. So before see the solar radiation, the prime source of the energy, prime radiation, the universe is the sun, and the sun is the nearest star of the planet to the earth, and diameter of the sun is 1.6 kilometer, and the average distance from the earth of sun is 1.5 into 10 raised to 8 kilometer, and the temperature of the sun is 1600 degree Kelvin. And we already have discussed the different unit of the temperature like the Fahrenheit, Kelvin, and the temperature. So temperature of the sun is important because the Stephen's-Boltzmann law has stating that the radiation is depend on the temperature of the radiated body, that is sigma into 10 raised to 4. So every minute the sun radiates approximately 56 into 10 raised to 26 calories of the energy, and all the universally energy supply is only when the source is available in the sun. So solar radiation is an electromagnetic radiation you have seen here, like the Olympic or any function in the Western countries are arranged, and that the lighting they have made the light shows like this. These are all the small particles showing the electromagnetic waves. So these are nothing but the picture of the solar radiation of different waves. That is the if you ask in the examination, write the definition of the solar radiation. You can write it like solar radiation is an electromagnetic radiation ranging from about 0.25 to 4.5 micrometer or 250 to 400, 500, 4,500 nanometer in wavelength, and including the near ultraviolet, visible light, and near infrared radiations. So, agriculture is the exploitation of under its supply of nutrients and water by maintaining the plant growth. If the water and nutrients availability is ample and solar radiation is sufficient, then the maximum food production in the plant is observed. So the exploitation of solar energy under adequate supply of nutrients and by maintaining growth. So it is but natural that any efforts of thoroughly understanding of the solar radiation will be used for the its fullest exploitation by the crop plant. Nature and properties of solar radiation is the all of the energies receiving in the different forms, and heat is the one of the energy form, and heat is transferred three ways. Heat is from one, that is the radiating body or the energy emitting body, to the receiving body is transferred in three ways, that is conduction, convection, and radiation. We have learned from the 8th class in the science. This is energy transfer in the different ways. So we are interested here in the radiation. The energy transmission through space from the sun of the earth. Example of the radiation energy. So what is meant by the radiation? Radiation is nothing but the transfer of energy from one body to another body without aid of the material medium. That the medium may be the solid, liquid, or gas. The energy is transferred without any aid. Radiation is not only when radiation is absorbed by the surface of a body, heat is produced. Sometimes you ask in the examination true or false in the competitive examination, such types of distinct sentences. Radiation is a not heat. So sometimes as radiation is a heat. True or false and correct sentence. Radiation is a not a heat only when radiation is absorbed by the surface of a body, it is produced. This sentence is correct. Then for conduction and convection of the material medium is necessary, but for radiation material medium is not necessary because radiation takes place in the form of electromagnetic waves. The ultimate source of all the physical and biological process occurring on the earth is radiation received from the sun. That is why it is commonly called the solar radiation. 90% of the energy of the biosphere is receiving only the from the sun and 1% from the stars. 35% of the energy is contributed by ultraviolet and visible parts and 65% by infrared. You will see in the next slide the different wavebands. According to the wavelength, different types of the radiation wavebands, that is like the ultraviolet, then infrared, photosynthetic radiations, visible radiations, infrared radiation. The productivity of any crop is dependent on the amount of nature solar radiation received during its growing stage, and the knowledge of the global solar radiation, that is GSR, and net radiation, RN, and the photosynthetically active radiation, PAR. Photosynthetically active radiation is important for the crop estimation. The Earth receives energy from the sun approximately. We have seen five somewhere. These are the unit is change and the number may be the change. So solar constant is one study of the solar radiation. We have seen in the last lecture how we are receiving the light from the sun from the in the form of the radiation. So this is the Earth. This is the Earth atmosphere. So per unit area, suppose 1 by 1 meter area, that is square meter area, receiving or insulating the solar radiation is called as the irradiance, or it's called as the insolation. How much radiations is received in unit area, in unit time, is called as the irradiance or the insolation, and the outer layer or the atmospheric upper layer of the atmosphere of the earth, how much energy is receiving, that is called as the solar constant. And the solar constant value is 2 calories per centimeter square per minute, or 1.9. Somewhere it is written 1.94, but it is average is 1.9 and 2.02. In a recent measurement, 1.94 calorie per centimeter per minute, or 380 watts per kilometer. It is varies from if you have refer the different research papers, books, or some any material available on the net website. There is the different figures you have seen, but the average figure is taken the 1370 1380 watts per meter square. This is the value of the solar constant, means in unit area receiving the energy outer surface of the atmosphere, not the earth. Atmosphere, earth atmosphere is called as the solar constant. There are the bifurcation or classification of the solar radiations according to their wavebands. That is the short wave radiation is the 0.22 13 micrometer, long wave radiation 0.7 to 100 micrometer, and earth radiating, that is irradiating. And the radiations is the long wave radiation, what is more than the 0.9 micrometer, and photosynthetic active radiation 0.3 to 0.76 micrometer, and visible radiation 0.76 micrometer. So, whatever the radiation is received to the Earth surface, this is the atmospheric layer. This is a solar constant. Whatever the energy at the upper layer of the edge of the atmosphere, from which the out of that received energy at the surface of Earth, total radiation is received surface of the Earth is called the global radiation, and global radiation is the solar radiation plus sky radiation, that is diffuse radiation. In net radiation, the quantity of radiant energy remaining at the Earth's surface is called as the net radiation. Net radiation received from the outer layer of the atmosphere, that is from solar constant, to the Earth atmosphere, that is, and from which the energy again reflected back in the atmosphere. In the atmosphere by different ways, and remaining energy is called as the net radiation. So these are the electromagnetic spectrums, and in Marathi or Hindi, that is Kana Pihini Baza, Tambla, नारंगी, पिवळा, हिरवा, निळा, जांभळा, ताना पिहिनी पाजा. This is in the primary school we have this the light bands or according to the electromagnetic spectrum we are studying, and the from the this violet to the red, the wavelength is going to increasing. From the red to violet, it is going to decrease. Are interested. Most of the interested, some part of these ultraviolets up to the 300 here, and some parts of the near infrared 760 nanometers. So we are interested only this part of the solar radiation spectrum. The energy received to the Earth surface through the solar radiation from the gamma rays and X-rays, which is most probably received up to the Earth surface, but the energy in that radiation is 1.2%. Then ultraviolet radiation 7.8. Then light, photosynthetic active radiations 39.8, and infrared 51.2. From the infrared, near infrared 38, and far infrared, which are not useful for agricultural purposes, that is 12.4. So near about more than 50% energy from the received from the sunlight is utilized useful for the crop growth development. This is the table. So if you ask in the examination, according to spectrum of the light, the energy percentage, then you have to write this way. This is the length given in the micrometer, and this is the nanometer. Sometimes, according to the different studies, we are using the micrometer unit, and we are using sometimes nanometer. So, the energy received from the sun on an unit area exposed normally to the sun rays at the average sun or distance in the absence of the Earth atmosphere means if there is a clear sky, there is a no turbidity, no turbulence in the atmosphere, then the what is the structure, what is the energy receiving at the outer emitting by the sun. That is, sun is nothing but black body. 6,000 degree Kelvin is the temperature, and extraterrestrial sunlight. Here of this is a blue line showing the extraterrestrial sunlight is outer layer or of the Earth atmosphere, and this black line, this red line shows the emitted energy from the sun. This blue line shows the energy received outer layer of the atmosphere, that is solar constant, and this black line shows the terrestrial sunlight is received at the Earth's surface. It may be the surface of the ocean, it may be the mountain, it may be the plain. Om. Hello. Om. Hello.
Yes, sir.
Okay. I am audible and also the screen is visible.
Yes, sir, you are audible and the screen is also visible.
Okay. And these are given the different wavelength. So we have seen here the micrometer and nanometer. Okay. So this is the micrometer. So you are interested from this layer, that is the pilot. 300, sorry, 0.3 to 0.76. So whatever the ultraviolets and the gamma radiation, it is absorbed. Here above, zero is received on Earth surface. Is it right? The visible radiation, photosynthetic radiation is not absorbed. Near about 75% visible radiation or the photosynthetic active radiation received up to the Earth's surface, and some parts of the near infrared parts is received to the Earth's surface, which are useful, and very little part of the ultraviolet light is received Earth's surface because of ozone layer and whatsoever the water is available in the troposphere, stratosphere, that is absorbing these all the harmful wave bands, and also the here in the red and the other yellow wave bands, it is oxygen and water molecules available in the atmosphere, they are absorbing. If the sky is clear, then cloud cover, mostly cloudy condition is there, and the night, that is skylight, how much radiation, which type of the radiations and the different waveband is uh, receiving is shown in this graph. So this outer line is showing the energy, the radiation is received at the sea level of the Earth surface during the sky is clear. If cloud condition is there, near about 75% reduction in the solar radiation or solar energy. Then during the night, this line, dot line is showing during the night, about very less amount of the radiation is received. It may be from the stars and it may be from the scattered of the light. And from the crop surfaces, it is through the different vegetations. The vegetation there are line very negligible is receiving the spectrum because of absorption by the plant canopy. So already we told the definition insolation, that is nothing but the electromagnetic energy radiated into space by the sun, or the simply insolation is coming solar radiation. Factor affecting on insolation, The solar crystal distance from the Earth of the Sun, because Earth is rotating on its axis and also surrounding to the Sun. So distance is changing. Transparency of the atmosphere, duration of daily sunlight period, angle at which sun non-rays strike the Earth. Then depletion of solar radiation, the factors affecting for that, or the factors affecting on solar radiation is the distance from the duration of daily sunlight period, solar elevation, inclination of solar rays to the horizon, transparency of the atmosphere toward the heat radiation, output of the solar radiation. So we have seen the what about the solar radiation definition and some terminologies and how it is received, some graphs. That is a distribution of solar radiation received to the Earth's surface as the atmosphere and the Earth's surface. So here the annual daily, if you have seen the receiving the sunlight, this is a L-shaped curve which happened during morning and during evening. There is a less amount and the peak at the noon time. The similar, the yearly pattern is showing the same uh, percentage or same quantity of the solar radiation received to the Earth surface. So, whatever the radiation received at Earth surface different places, and if joining the line of the different places, that is called as the isohale. The same point of the solar radiation joined on the weather map is called as the isohale. So this is the data of the isohale of the India. The scaling is given here. The data of the isohale or radiation available at the Earth's surface is useful to determine, that is uses of the isohale data. Why you are going to study solar radiation, type of the spectrums and energy in each spectrum and how much it is receiving at different geographical places. So to determine the availability of solar energy, geographical location wise, hourly, daily, weekly, monthly, and annually. The data of isohale is useful research and development of solar which are useful to install, construct, run the units of solar electricity, solar heater, solar battery, and allied form for the mechanical industry. So this era is the renewable energy era. All the energy of renewable energy is utilized, used in the different, in the mechanical purpose, in the agricultural purpose, and electric purpose, so many purpose. So this is very important. If you have the data, you know how much energy is receiving hourly, daily, and weekly in different places. Then you can decide. You can make some instruments installation and all these things. It also be useful for the research and development in agricultural and oil sector to development the crop variety. The changing the isohale, changing the energy, so which type of variety should be developed, how it is developed, also the rearing animal development, birds, breeds, climate smart techniques like management practices for enhancing and sustainable crop and animal husbandry and dairy science, poultry, fishery, etc. Marketing, storage, and processing. All these purpose data is useful. So therefore, the solar radiation and how it is the available energy through the different spectrum of the solar radiations is useful in agriculture. So this is shown the monthly average global insolation maps in India, showing the data which places of the month has showing. This is the January to April shows the more available energy of the sun is here. Then here shows the May to August data in the central India in the monsoon period is less. And again, the annual global insolation map has shown here means the western side of the Indian part and also some the eastern northeastern part has the more energies available for the renewable energy production and also the utilization. And some projections in the future has shown here. Month-wise, the bell-shaped curve of the isohel data, and here the some projection climate change studies has done from the 1880 to 11 year average has taken of the temperature and isohel. So this is a radiation data. So yellow line dot line shows the radiation. It shows after the 180, it is continually going to decrease. It means that the solar radiation received on the globally is reduced and the temperature is going continuously increase. So I feel this is a small part regarding the solar radiation. Its characters means what is the energy in this spectrum, type of spectrum, different types of the radiation, that is long wave, short wave, infrared, ultraviolet, and their what is their the wavelength. Like the isohel, then the data on the graph of the isohel in India, and also the projections of the climate change. Maybe in the future, the solar and radiation energy may be going to decrease. This is one type of the hypothesis based on the historical data. So thank you for this solar radiation characteristics and some information about this. So any question regarding this in a store? If you are will to join again, I'm going to send immediately the second link if you want to discuss it. Any question? Any question?
No, sir.
Yes. Smita Kumar. Hello.
Yes, sir.
Any question?
No, sir.
Okay. Then you understood all these things, whatever I explained in this class.
Yes, sir.
So what is the use of this class? Practical use of this class. Explain in 1 or 2 lines. Raut.
हाँ sir.
Explain utility of this class in agriculture. Your agriculture student.
Yes, sir.
Shreya.
Yes, sir.
Can you able?
सर अगर किसी पर्टिकुलर लोकेशन पे हमें सोलर रेडिएशन